Thank you so much for joining us on this sunny evening for our second talk about climate change. Before we undertake this talk, I'd like to first acknowledge the traditional territory of the Squamish First Nations. We aren't physically gathered together here today, but most of us are on the traditional territory, their traditional territory. I would now like to hand it over to Mayor Elliott for a quick introduction. Thank you.
Thanks, Ian. My pleasure to help kick off the second of this four-part series on climate change in Squamish. So it's important for people to know that the district has approved and adopted our Community Climate Action Plan. And this plan had the input of the community, a great group of local experts who served on our climate leadership team, as well as support from our staff and the Whistler Center for Sustainability and the Community Energy Association. And that report can be found on our website, along with a really excellent executive summary if you don't like reading long documents. But it's a great starting point for us as a community. So the plan outlines 6 big moves, which I think Ian will talk about, so I won't take up the time here. And likely none of these will surprise you or shock you. They're quite intuitive. But these are the key steps that we have to take to reduce our greenhouse gas emissions in line with the climate goals we've set for our community. One of the lenses that we've asked our staff and our community to consider as we talk about climate change, whether mitigation, which we'll talk about tonight, or adaptation, is the issue of equity. And we want to make sure that everyone in the community can participate in the discussion and benefit from our actions around climate change, not just those with means. And that's something that's really important to Council and something that we'll be thinking of throughout this whole process. So as I learned last week during Ian's last talk, is that I don't know everything. There's still lots that I can learn. I really appreciated the interactive quiz. And I hope you'll enjoy this evening's talk and find it really informative and help shape your thinking about actions we can take as a community in the days and weeks and years ahead. This is an all hands on deck plan, and we'll need everyone's energy to make things happen. So I'll turn it back to you, Ian. Thank you.
Thank you so much for that introduction. So for those of you who don't know me, my name is Ian Picketts, and I'm relatively new to the District of Squamish. I am the Manager of Sustainability and Climate Change. And before taking on this role, I worked for a number of years as a professor at Quest University, where I taught courses on resource management, earth sciences, and climate change. This is our second of 4 presentations. So the last one was very much focused on the scientific underpinnings. And now we're going to start to change gears and start to look at the human responses. So same as last week, why are we giving this lecture series? First and foremost, it's important to establish and kind of nurture a community of learning and action. This is something that has been really hard to do during COVID. It can be a really alienating time, and it's certainly something I have missed, coming together with people to talk about ideas related to the environment. So this was a format that we can try to do it in and experiment. So today we're going to try to up it up a little bit and make it more interactive. So there'll be times when there's a couple discussion questions. So feel free to raise your hand, and you can actually get the audio turned on and ask a question, or you can send in a text chat. Another reason to do these is as a resource. So hoping that some teachers can use these in some form. A lot of teachers out there working very hard in adjusting to a virtual schedule. It's very, very busy and very overwhelming. So maybe teachers are going to pick these up and assign them or build from them. And finally, climate is a challenge, and I'm not hesitating from making these challenging. As Mayor Elliott noted yesterday, just a minute ago, last week, I certainly included a lot of very complex information that I certainly struggled a long time to wrap my head around. So in that spirit, we're going to keep asking tricky questions and challenging ourselves. So for today, we're going to start with a very quick recap from last week, and then we're going to look into some major ways humans can respond to climate change. Most of you, when you ask how we can respond to climate change, will think of adaptation and adjusting to impacts, or mitigation, lowering the greenhouse gases in the atmosphere. But another interesting way that we can respond to climate change is we can write really big reports. So we're going to talk about the Intergovernmental Panel on Climate Change a bit. This is probably something that a lot of you aren't aware of. If nothing else, it is a pretty impressive undertaking, these reports. So just mostly out of interest, thought that some of you might like to hear about the process through which these are created. Then we're going to focus in on mitigation in Squamish. So look specifically at the Community Climate Action Plan and focus more on the modeled emissions. So what is their business as usual scenario, and where does the plan get us? My thinking is that we're not going to talk about the CCAP quite as much as we'd like today, but next week we'll open off the presentation with a little more talking about that, and then we'll transition over to adaptation in our community and in general. So very quick recap. We have this lovely phenomenon on Earth called the greenhouse effect. So most of our energy, almost all of our energy, comes from the sun, and it comes, the sun burns very hot, so it's a very high energy radiator. So most of the energy we get is in the form of light, and then some of the energy gets reflected back by our atmosphere. Some of it makes it to Earth and gets reflected back by things like snow and light surfaces. But most of it gets absorbed and re-radiated as infrared radiation or long-wave radiation or heat. And we have these greenhouse gases in our atmosphere, things like carbon dioxide and methane and water, that trap some of this heat very quickly and re-radiate. So this is the reason that Earth is about 15 degrees Celsius on average rather than about minus 18 degrees Celsius. So it's a very good thing. However, it's something that we have been manipulating over a period of time, of course, by putting more greenhouse gases into the atmosphere. And that is actually only a part of the story. We also have these positive feedback cycles at play on Earth. Most of you are probably more familiar with negative feedback cycles, or things that dampen each other. So something like a predator-prey relationship. If there's lots of moose, then wolf populations increase, and then there's less moose, and then there's less wolf populations. But positive feedback cycles serve to reinforce each other, so they can really exacerbate or echo other effects. So just a few of these positive feedback cycles are the snow ice albedo. So when you have a lot of ice in glaciers or in sea ice or in snow, that tends to reflect a lot of the incoming solar radiation. But when that melts, particularly over the ocean, and you have a lot of water, that tends to absorb most of the incoming radiation. So that's a positive feedback cycle. So more heat equals less snow equals more heat. The biggest one is actually atmospheric water vapor. The warmer it gets, the more water vapor our atmosphere can hold, which is itself a greenhouse gas. Other ones include permafrost melting, forest fires, ocean die-off, which is essentially if we get to a point where the acidity or the temperature of the ocean is not amenable to most life, we'll see a large dying off of photosynthesizing agents, and they will cease to become a sink, or they will cease to absorb CO2 and become a source as they die and decay. So those are positive feedbacks. So we're going to start with a quick quiz. Those of you who were paying close attention last week might remember this, but it's a very tricky and long question. But based on the greenhouse gases that we put in the atmosphere, so if we were to put twice as many greenhouse gases in the atmosphere as there were before industrial times, so there was about 280 parts per million, if we bump that up to 560 parts per million, just because of those greenhouse gases, Earth's temperature should increase by about 1.6 degrees Celsius. However, those positive feedback cycles increase that effect. However, due to positive feedback cycles, how much do Earth's average temperatures actually increase by, what we think, by a doubling of greenhouse gas concentrations? So is it 2 degrees, is it 3 degrees, is it 4 degrees, or is it 5 degrees? So we'll give you a minute to ponder that, and please go to the poll and take your best shot. Don't worry, your name is not attached to your answer, except in Mayor Elliott's situation. Her answers will be published. Okay, so it looked like the overwhelming answer was 4 degrees Celsius. So it was a little bit of a disingenuous question, because you could make an argument that 2, 3, or 4 are right. They are all in the range of sensitivity. So the range of sensitivity, scientists think it's about 2 to 4 degrees Celsius, where there's a lot of uncertainty, particularly because of water vapor. But the middle of the range, the most common estimate is more about 3 degrees Celsius. Those of you who are interested, there's a really good explanation on the link that I've provided at the bottom of this slide, and we will put up on our website afterwards. So the positive feedback cycles roughly double the response and also add a great deal of uncertainty. So 2 to 4 degrees is about the climate sensitivity, and 3 degrees is about the median. So this is where we are right now. The latest CO2 reading, just from from May 23rd, is 400. Actually, the reading is from May 26th. Sorry, I forgot to update the graph. So from 2 days ago, we were at 418 parts per million, roughly. That is up. If those of you remember, we were at about 417 last week. So this number does oscillate quite a bit, but it's been steadily trending upward. And we are essentially in the midst of a pretty unprecedented and very high stakes experiment. What happens when we rapidly increase CO2 emissions in our atmosphere? We're quite certain that the answer is that temperatures increase and precipitation becomes more extreme, but we're not quite sure what that means. So it becomes a really tricky question of risk management. So this slide we also got to last week, but we didn't talk about it that much. So what you see on the left is the black line is past temperature trends, so temperatures have increased by about 1 degree in the last 150 years. And the blue line is a projection. So this is based on climate models with a certain scenario, or with greenhouse gases in a RCP 2.6 degree scenario, and 2100 were about 1.5 degrees above pre-industrial temperatures. And the red line, or the RCP 8.5 scenario, is a business as usual scenario. So this assumes that we keep doing things very much in the way we have been doing them for the past 50 years. So, we keep relying a fair amount on fossil fuels, population continues to increase, etc. So you will notice in 2100, we have temperatures that are somewhere in the order of 1.5 degrees Celsius above pre-industrial times in the blue line, and somewhere in the neighborhood of 4.5 degrees Celsius above pre-industrial temperatures in the red line. That's a very big difference, and that's a very, very important difference. So scientists have said that 2 degrees Celsius is kind of a maximum threshold of change that natural and human systems can generally accommodate. It's a very tricky number to land at because, of course, 2 degrees Celsius change in Canada might mean a very different thing than if you lived in sub-Saharan Africa or if you lived in a Pacific island. So 2 degrees Celsius is seen as like a very uppermost limit, and most scientists believe that 1.5 is a much more appropriate, safe limit. It's still not ideal. There will still be unpleasant consequences, particularly for some areas of the world, but it has been generally kind of landed upon as a goal to shoot for that is achievable, yet very ambitious. And we're going to get to that more today. So I won't go into this in a lot of detail, but one of the reasons I sometimes include this slide when presenting is that it really bugs me when people come up with the idea that climate change and climate science is very rapidly new and a bunch of scientists just thought it up in the last 20 years, where in actuality, we've understood a lot of this for quite some time. So Tyndall proved the greenhouse effect, the fact that these gases trap infrared radiation and re-radiate it. That was proven over 150 years ago in 1859. In 1900, Arrhenius determined climate sensitivity is about 2 to 4 degrees Celsius. One thing that's really interesting is that level of uncertainty hasn't actually gotten smaller. We still don't quite know. We still, because there's just so much complexity in the system in those feedback cycles. So then we move along, and in the 70s, James Hansen was able to conclusively show that changes have occurred and they are related to humans. So in 1988, Hansen testified that he was 99% sure that the recent high temperatures in America were due to a human forcing. So we've actually had scientifically a consensus on this for 30 years. And the Intergovernmental Panel on Climate Change was created after the scientific consensus. It wasn't created to figure it out what was happening. It was created after the general scientific community agreed that it was happening. So the Intergovernmental Panel on Climate Change was put together in 1988, and their role, so they were formed by the UN Environmental Program and the World Meteorological Organization, and their mandate is to assess information produced relevant to the risk of human-induced climate change and our responses. So really important to note that the IPCC does not conduct any research, it doesn't fund any research, and it doesn't actually collect any data. And also it doesn't provide any policy recommendations whatsoever. It is strictly an information, kind of a place to go to get very, very comprehensive aggregated information. So that is the role of these reports. And I just wanted to include a couple slides because the scale of these is pretty profound. So this is the process through which they created the fifth assessment report, and those came out in 2013, and a couple of them actually didn't come out to 2014. So what they did is they had a meeting where they selected authors and editors, very complex process. So they want they want the best scientists. They want good representation from genders, nationalities, both developed in developing countries, different areas of the world. So a very, very tricky process to select the authors. And then the authors go and they write the reports for these chapters, and they come up with a first order draft. And then they open it up for comments. Essentially, anyone in the world is allowed to create comments on these, and the authors have to respond to all critiques in writing. You can actually you can actually find these, they're just essentially giant Excel sheets that have comments and multiple responses from a number of authors from each of the chapters. So then they take in those, and then they put it back out for revision. So for the first working group, which is the scientific basis, they got about 53,000 comments for the first report. And then finally, they send out a final draft to governments, and then the government scientists provide feedback as well before they're finalized. So just to try to put it into context, so we have 4 reports in the 5th assessment reports, and one of those focuses on adaptation. This report is 3,000 pages long. It has 30 chapters and cites 9,000 studies. And one of these is chapter 15. And if you go to page 881, you will see a paragraph that has 4 citations. And one of them is from one of the studies that I did. And that study took me about 2 years. And there were 4 co-authors on the journal article I wrote. So that took, a big proportion of 2 years of my life, of my PhD work. And it's supporting one sentence or one paragraph along with about 4 other studies. So just to give you an idea of the scale of these, it's just a very impressive aggregation of data and assessment of them. And I'm providing you with the kind of the nuts and bolts. People certainly have strong opinions either way about these reports and how useful they are. They also have a synthesis report, and a colleague of mine, Francis Sweers, is one of the convening authors. So he was able to explain to me in a lot of detail how they go about creating this. So imagine this, they come up with a summary because they realize no one's going to read a 3,000 page report, particularly high-ranking government officials. So they come up with a 20-page report and a bunch of headline statements, and then all the governments that are members of the IPCC, about 195, are invited to a 5-day-long session where they go through every single line of the report and come to consensus on the language. So it took 5 days. Each day was 18 to 22 hours long, and they had to reach consensus on the language. Francis is a remarkably patient individual. I could not imagine a more miserable way to spend 5 days. Kind of interesting too, if you get him talking, he'll start to They'll start to allude to which countries are kind of more nitpicky and which ones aren't paying attention and stuff. It's really fascinating. But the one way he said it is the process is really empowering for the countries because they can take ownership of the report and feel like their voice has been heard in it. So when you're perusing the synthesis report, it's interesting to recognize that that is the process through which it was created. And so now I want to encourage people to reflect on this. Please, if you want to send a response, please do so in a text form, or you can put up your hand and we can unmute your mic and you can pitch in. So the prompt I have here is that the IPCC assessments are very comprehensive and challenging you to think about what are some benefits of the reports in the process and also what are some drawbacks of them. And then finally, do you think the IPCC should keep putting huge amounts of energy into creating these assessments? Are they worthwhile? Do we need them? Do we know enough? Yeah, just really interested to what you think about these. So yeah, give it a few seconds to think in, and then if you want to, you can put up your hand digitally or send in a text message, and it'll be related to. Okay. Apparently there's a 13-second delay. So. No, it's an odd format to chime in. I'm still not totally convinced I'm talking to anyone but Sandra over here. All right, maybe we'll save, we can do some questions later on. But one of the really big critiques that are levied against these reports is that they're so big and comprehensive that it takes such a long time to put them together that by the time they come out, the science is already a little bit dated. So in 2014, the last things they could have really cited are from about 2011 and 2012, and it takes a couple years to do scientific research. So that's one of the drawbacks of the process is they're not very nimble. They're kind of clunky. And another thing is that by coming to consensus, you tend to come to fairly conservative outcomes. So some people criticize these reports as not being, as being a little bit too hesitant to and conservative, only sharing what is absolutely positively known. So the reality might be a little bit worse. Some benefits of the process are that they're entirely non-political and they provide no recommendations. So the idea of them is hopefully that these settle the science and then the government leaders, et cetera, get to argue about what to do about it. Whether or not that happens is very much contested. Of course, people have attacked these pretty hard. Yeah, and open to debate whether or not, people should keep putting years in their life into these assessments, or should they put work into other actions. So here are just a couple of quotes that from Francis that I thought were pretty interesting. I phone interviewed him the other day just to kind of get his feedback on him. So in the top right, kind of the same thing that I just said. It's hopefully this part of the problem is settled, the science. Now the governmental leaders should figure out what to do with them. Another thing that I didn't think about totally is how empowering the process was, particularly for some developing countries or that have less resources of being actually helping to hold the pen to create these. Another comment he said that I thought was pretty interesting is that you can't negotiate that the climate is warm, but you can still negotiate the words. So things like you won't see very little recognition of, say, oil and gas exploration. It's usually termed as like energy development, etc. So people really call out certain things very, very quickly. So as most of you are aware, the latest special report of the IPCC has a very short and pithy title of Global Warming of 1.5 degrees Celsius, an IPCC special report on the impacts of global warming of 1.5 degrees Celsius above pre-industrial levels and related global greenhouse gas emission pathways in the context of strengthening the global response to the threat of climate change, sustainable development, and efforts to eradicate poverty. You'll notice brevity is not one of their strengths. They can be very, very much a wordful, but essentially in 2018, the IPCC put together this report that articulated very specifically how and when we will exceed 1.5 degrees Celsius of warming and what we need to do to remain below it. So it was a targeted report, didn't quite have the same process, and it answered a much smaller subset of questions. So we're going to have our next little pop quiz. In order to limit global warming to 1.5 degrees Celsius, scientists estimate that anthropogenic or human-caused global emissions must be net zero by approximately this date. Is it 2040, 2050, 2060, or 27? Give you a minute to discuss that, your friends. Oh, I might have just given away the answer. Okay, good work, everyone. It looks like overwhelmingly the correct answer was landed upon. So the IPCC believes that we have to be net zero. So anything we emit, we also have to be removing carbon CO2 equivalent from the atmosphere by approximately 2050. So that is no small task and involves a pretty significant rethinking of a lot of the things that we do. So it's really interesting. I don't think it's fair to attribute all of the recent attention to the IPCC report, but there's been quite a storm of activity that has really resonated with people and really brought climate action back to the front of people's minds. And it seemed like in a way that it hasn't in about a decade. Some of the actions include the very unfortunate events, extreme events that we have seen of late, notably the large fires in Australia. Also, Greta Thunberg has articulated a very, very forceful sentiment of youth and the generational inequity that comes with climate change. So this has led to large gatherings and a lot of public pressure on leaders to start acting quickly. And a very different kind of rhetoric around climate change, a little bit darker than we've seen in a long time, but really framing climate change as an emergency. This has to take precedent over other things and has to be dealt with quickly if we are to provide our younger people with the same opportunities that we've enjoyed and all of the amazing things that come with a predictable and more temperate climate. I don't know about you, but it certainly resonates with me. I had to watch some of her statements in very short bites because I found them so powerful. I had to kind of walk around and digest them. So, but there has been really, really strong sentiment about this for quite some time. It's very quickly to forget this amid COVID, but I suspect that if and when this passes, climate change will return to front of mind very quickly. So in light of this, the District of Squamish passed a climate emergency resolution on July 2nd, 2019, as Mayor Elliott articulated before. And as part of that emergency resolution, several declarations were made, including that the district make a plan in line with the 1.5 degrees Celsius targets. So that means that the district has committed to reductions of 45% by 2030 and 100% by 2050 compared to the 2010 baseline. So here is the vision of the Squamish Community Climate Action Plan, which is essentially what I just said. One thing to keep in mind is that this plan doesn't think that much toward 2050. It's much more focused toward 2030. One of those things with the technology, with the economies, with the social, all of these things in such a state of change that it's much easier to plan for something that is 9 or 10 years ahead than 20 years ahead. We just might see entirely different technologies, entirely different priorities in that. So in 2030, Squamish has committed to being 45% below 2010 baseline levels and be working toward that net zero by 2050. strong links with the official community plan and also council's strategic plan. The one thing to keep in mind is that the scope of this plan is somewhat limited. Firstly, it's only talking about mitigation. So there's nothing about adaptation or adjusting to the impacts in it. However, we really want to be keeping that in mind. The last thing you want to do is to increase vulnerability by mitigating. The other thing is that it is limited to community emissions. So as an example, indirect emissions, so if I was to take a flight, that wouldn't be counted as part of the community emissions, although it's still associated with me who lives in Squamish. And if one of my kids was to buy a plastic toy, the emissions associated with creating that wouldn't be incorporated. It also doesn't include industry emissions or things related to forestry or land use change. A couple big assumptions. One of them is that Squamish continues to have access to abundant low-carbon electricity, and we're looking at 100-year values. If there's questions about that, we can get into it, but it doesn't change things that much. So our next question, in Squamish, as in very similar to a lot of Canada, we consume a large amount of energy. So by consuming energy, we consume energy as in joules of energy, and we also emit greenhouse gases associated with this. So which of these four statements is true for Squamish? So we consume the most energy from buildings, but we emit the most greenhouse gases from transportation. We consume the most energy, so joules, from transportation, but the most greenhouse gases, or CO2 equivalent, from buildings. Or we consume the most energy from buildings, but emit the most greenhouse gases from our waste. Or we consume the most energy from transportation and also emit the most greenhouse gases from transportation. There were a couple little hints I dropped earlier that you might have picked up on that might help you in your answer. Give you a few seconds to chew on that. I recognize that it's a tricky worded question. Okay, so the answer is that we spend the most energy, so we consume the most energy from buildings, and we emit the most greenhouse gases from transportation. So that was A. Yeah, so this is really interesting to look at. So as you can see from waste, we don't consume any energy and we don't spend any money, but we emit greenhouse gases. And so primarily it's transportation and buildings. And as you can see here, there's really big opportunities to save money. We typically spend money where we also emit CO2. So this would be pretty different in different areas of Canada. In British Columbia, we're pretty lucky. Our hydro is our electricity overwhelmingly comes from hydro, which is relatively quite low carbon. So buildings usually, so electricity is from hydro, and heating very often comes from natural gas, which has lower CO2 equivalent than gasoline from transportation. So, it will be really interesting in the next 20 years to see how this changes with the advent of electric vehicles. However, hopefully we're doing other things differently as well, so they're all going down. And they all certainly need to go down to hit the targets. So this is just a different way to look at this same information. Transportation collectively is about 52% of emissions in the District of Squamish. This is fairly in line with most other communities in BC. However, our solid waste is a little higher than a lot of BC communities, particularly because we don't have a landfill gas capture system in our landfill as of yet. Okay, in the interest of time, maybe I'll just say this and continue on. But as Mayor Elliott noted before, one of the worst things about climate change is that it's very inequitable. Poor areas of the world are typically hit harder and also have had less of an impact on the climate themselves. So one of the things in Squamish that we need to be really careful about is the last thing we want to do is create a plan that isn't accessible to a large amount of people. So for example, we can't make the assumption that everyone is going to buy an electric vehicle or retrofit their home because those things are very expensive and not everyone owns vehicles, and not everyone owns homes. So very tricky and very important to think about ways to make climate action equitable. So some of the things that we thought about, and first to admit that this is something that needs to be continually improved, but some of the things to enhance accessibility that we've incorporated into the report include incentives, so ways to make certain things cheaper or to reduce the kind of the cost of a loan or something like that, so financing options, etc. Other things are education and engagement, events like this that can bring people together, and trying to make climate action fun. So like friendly competitions, trying things like Bike to Work Week, getting people together, and celebrating simple low carbon lifestyles. So things like tiny homes or biking, or people who don't own a vehicle, etc. Trying to think of ways to celebrate that. So those are just some of the things that we've been working toward to try to make this accessible to a larger number of people. And of course, transit is a really good way to do that, rather than investing all of our money in electric vehicle charging infrastructure. Also, doing that is important, but also, or electrifying transit would be a great win-win with equity and emissions reductions. So on the next slide is the business as usual emissions projection for Squamish. So there's a ton of information here. We essentially were able to hire greenhouse gas modelers who looked at our emissions from 2010 to 2017 and then projected how those would change over the next 30 years. So this incorporates population growth. This also incorporates some other actions that higher levels of government are committed to. So for example, the BC building code is changing. So even if Squamish doesn't do anything, emissions associated with buildings will go down. Also, emission standards for new vehicles are getting better and better. So as you can see, emissions stay about the same in Squamish, even though population increases. However, you can very clearly see us getting absolutely nowhere near our targets. So that line goes about straight, and the 1.5 degree target is the red line. So there's a lot of work that needs to be done to get down to that target. And this was the challenge of the community climate action. So in attempt to meet these targets, we consultants, I came in partway through the process, so I certainly can't take credit for it, but I worked a fair bit toward the end of it. So the group articulated 6 big moves, which are big categories of actions that need to be taken. And for each of those big moves, we came up with a few strategies, 4 to 8 broader strategies. And then within those strategies came up with 2 to 7 actions. So a good example is for one of the big moves is to reduce greenhouse gases associated with waste. One of our strategies is to capture landfill gas. And then one of the actions is to implement a landfill gas collection system. So it kind of goes from very big scale to a direction to tangible actions. And the actions are really interesting because there's different things that you can do as a local government. So some things you can just tell people to do and do them. Some things you can incentivize people to do or ask them nicely to do it or make things cheaper for them to do it or reward them to do it. Some things you can encourage people to do through education. And then sometimes you need to partner with other groups or orders of government. So depending on kind of the teeth that the local government has, different techniques need to be used. So it can get really interesting and really tricky trying to leverage actions that you don't necessarily have as much jurisdiction over. So my plan is today to just quickly introduce these and then next week to look at some of the actions in quite a bit more detail. But the 6 big moves are, number 1 is close the loop on waste. So very big priority there is landfill gas, looking at waste reduction, and also wood waste management. Those are significant sources of emissions in Squamish. Those are also happen to be things that the district has a lot of authority over. So those are changes that can be made. Some of them aren't cheap, but they can be made and have a very big, known, quantifiable effect on emissions in the community. Actions 2 to 3 are related to transportation. So number 2 is shift beyond the car. So that looks much more at transit and active transportation. So different ways to incentivize these types of activities. And then number 3, so 2 and 3 are kind of complements to each other. Number 3 are decarbonizing vehicles. So providing electric vehicle infrastructure, making it easy for people to own and use EVs, or maybe harder for them to own and use traditional combustion engines. Number 4 and 5 are related to buildings. Number 4 is decarbonizing existing buildings and constructing, and number 5 is constructing better buildings. This one is really fascinating because the municipality has a lot of say in how a new building is created. However, once it ceases to become a new building and someone owns it, they all of a sudden have remarkably little say over what happens. So it can be way harder to incentivize a retrofit than to construct a better new building. And of course, buildings have a very large kind of legacy of carbon associated with them. So if you build an old, leaky, inefficient home, chances are it's going to be old and leaky, or no, you don't build an old home, sorry. It's going to be a leaky and inefficient home for decades. So it's a really good chance to nip a lot of emissions in the bud. And the final is other organizational activities. So these are kind of bigger picture things to help support the other moves, help move us toward this. So things like encouraging economic activities that are low carbon, maybe setting an internal price on carbon, maybe hosting workshops to bring people together to share best ideas, etc. So this is kind of the constructional framework of the Community Climate Action Plan. And to achieve these targets, each of these 6 big moves, a number of different actions will have to be taken for each of them. So here's the projected outcome of the Community Climate Action Plan. And I'm putting this front and center here because we're going to have some time for discussion and questions in just a couple of minutes. And I'm really interested to hear what people think, because this was the cause of a lot of really, really in-depth discussion. The community established a climate leadership team. So there were 8 people who had a lot of expertise and passion about climate change that were brought together to guide this plan. And one of the big ideas that we struggled with is whether or not to have a plan. We have a target for 2030 and we need to hit it. But is it okay for our plan to not quite hit that target? So we ended up coming to the conclusion that it was okay for this plan in 2020 to not have enough actions to hit the 2030 target. And the reason that we came around to this, it was just the acknowledgement that between now and 2030, we're going to have to do more. There's going to be new technologies. There's going to be other changes that come. So it kind of is a hint at, it accepts that the plan is not complete. It is an iteration, it is a starting point, but it is no way kind of a roadmap. So the plan does not have enough to hit our target. You'll also notice, as I said before, this plan doesn't worry too much about the 2040 and 2050 targets. We know we have to get there, but as 2030 comes closer, then all of a sudden we're going to be as we get closer to 2030, we're going to switch our attention to 2040 and 2050. This isn't a plan for 2050 yet. And the next slide, I kind of alluded to this earlier, but interested in your thoughts and some discussion on it. Here's just a bit of a spectrum of actions that local governments had. So there are certain things that we have clear authority over and control and pretty proven low-risk approaches. So things like waste. There are things that a local government can do to affect the amount of emissions associated with waste. There are things the local government can do that they have clear authority over, but they have less control over the outcome. So for example, a local government can spend their entire transportation budget on active transportation, for example. Some of the councillors might not get re-elected, but they could. Or they could put a huge amount of resources into electric vehicle infrastructure. However, they can't make people ride their bikes or buy an electric vehicle. but you can kind of lead a horse to water in some of these, and sometimes you can do it pretty convincingly, but there's not control over the outcomes. And then finally, there's certain things that a local government has limited authority over, and there's barriers to progress at scale. So something like existing buildings. There's not much that a local government can do at this point to make a homeowner retrofit their house, or to incent a commercial owner to transition to a low carbon fleet. So really interesting to think of this kind of spectrum of actions. You can tell people, you can ask people, and you can nudge people on all of these different things. However, you can't just focus on the ones that are highlighted in blue if we're going to get anywhere close to those targets. So again, the plan is 6,200 tons of CO2 equivalent per year short of the 2030 target. And we spend a lot of time in the report really trying to clearly articulate that although the plan doesn't hit the target, it is not a plan to fail. So what we wrote was that we have to learn more, we have to do more, we have to adapt, we have to adopt, and we have to iterate. So the plan is a starting point, but it absolutely is not. It is not a roadmap, and we still have to keep adding to it and updating it. And I'm really interested to hear your thoughts about that. I'll admit it was certainly something that I struggled with for a while. And yeah, and there's, that's one of the interesting things about this is as you get further into the kind of human actions, I personally find the science of climate change, although challenging, it's almost easier because there's questions, there's answers, there's energy, there's balances, there's budgets, and you can arrive at an answer. And once you start putting humans into the equation, your responses get more and more tricky. There's all of this interesting psychology and the way people react, etc. So, this is a good example of these tricky kind of wicked problems. And how do you incent people to act? How do you tell people to act? How do you ask people to act? And how do you bring people together toward a common goal? So with that, I would like to invite people from the audience to make questions or comments. You can do this by raising your hand, and I can't see this, but it should be on the right of your screen. There's a little hand button. So if you're feeling brave and would like to do that, our moderator, Christina, can unmute you, and you can ask a question or make a comment, or you can ask a question or make a comment in the chat. So yeah, thank you very much. And I look forward to questions. If you have questions or comments related to the IPCC reports and some thoughts about those, please jump in. Also, if you have any comments or questions related to the second question, which was regarding equity, ways to make a plan like this equitable and accessible and inviting to a broader segment of the community. Thank you very much. If there is not a ton of questions, I can go over a couple of the actions, but we'll see how this goes. Just as you're thinking too, I'd like to take a minute and thank our communications team. They're putting a huge amount of energy into these presentations and really supporting me and encouraging me to kind of experiment with this technology. So it's been a lot of fun. Oh, so there's a question from. So a question just came out. When is the next IPCC report coming out? And that's an excellent question. So they have convened the 6th assessment report, and it was supposed to come out in 2020. It is now supposed to come out in 2021-2022. The processes are so large that they tend to take longer than previously. Things tend to go over time. So 2021, 2022, we are hoping to get the next IPCC assessment report. And one thing to note too is the IPCC isn't mandated to produce these reports. So whether or not they'll do another one after that is open for speculation. Okay, an excellent question. It's been noted that the plan has left emissions out of the inventory, but don't we need to address all emissions, regardless of inventory, to meet the IPCC objectives? And Chris is absolutely correct in this. So the Community Climate Action Plan has decided what is in scope for the community, and that was mostly decided by kind of higher levels of government attribute certain emissions to certain levels of government. And it also relates to what the local government has kind of jurisdiction over. So if certain things that the local government has no authority over, for example, forestry practices and on Crown land, aren't incorporated into the inventory. But all emissions have to go down by these amounts. That's an absolutely excellent point. So there needs to be a climate action plan for every sector at every level that eventually accounts for every kind of molecule of greenhouse gas that is emitted. So, even though the fact that the toy that I bought my child 2 weeks ago has all of these embodied emissions associated with creating it, those emissions have to go down by 45% and eventually 100% as well. So absolutely correct. And as you get lower and lower in the emissions, it's very interesting. The 2.6 RCP scenario actually involves quite active removal of CO2 from the atmosphere. So as we're getting further and further along with this experiment, for lack of a better word, we're going to be starting to look at more kind of engineered or potentially more radical ways to manage Earth's energy budget. So, one of the big ones, and it's actually only about 500 meters to the south of me, there's a group called Carbon Engineering that's actively exploring ways to get well-mixed carbon out of the atmosphere. So a pretty fascinating undertaking. Other groups of people, there's groups of people that are looking into solar radiation management, which is a fancy way and less scary way of saying figuring out ways to block some sun coming in. So doing things like injecting sulfates into the atmosphere. So, the further along we get, the more, for lack of a word, creative we'll have to be. Okay, question. So how will you reduce the 50% in transportation emissions? Electric vehicles go a long way for this. So EVs it's kind of neat because the carbon emissions associated with an electric vehicle, it's slightly more emissions to create the vehicle, largely because of the battery. Estimates are anywhere from about 20% to 50% more emissions than a standard car. However, the emissions associated with driving an EV in British Columbia, when you're using hydro, it's about 3% of the emissions per kilometer traveled. So kind of the break-even point is only about 30 or 40,000 kilometers. So we could get well below the 50% just by, we could get to about 35 or 40% by giving everyone an EV or making everyone buy an electric vehicle, which of course you can't do, which is of course very expensive, which of course there aren't even that many electric vehicles. So the targets are through mode shift. So for 2030, the targets are to double the amount of people taking active transportation and transit trips, and to 50% of new vehicles will be electric vehicles. So those two together don't quite get to the 50%. We are getting a little bit more from waste. So some of the big moves we're doing better than others at. This is one too where the modeling is pretty tricky, that there's not many communities out there that have been able to really radically reduce the amount of private vehicle trips. And we're hoping that we can prove these models wrong, because no model is perfect. It's just an approximation. And we're hoping that through mode shift, through encouraging active transportation, through densification, through better transit, that we could get the amount of private vehicle trips way down, and maybe reduce that by 30 or 40% and get past 50. Thank you. That was an excellent question. Oh, one thing that the person who asked about the next IPCC report, just as this is getting figured out, is what do you expect it might say? That's a really good question. There's probably not going to be much different than the last IPCC reports. The the conclusions of them all have not changed markedly. The one big change in the last one, the 2013, 2014 ones, compared to the 27 ones, is unfortunately the climate change is much less reversible than was previously thought. So basically, if we warm the climate by 2 degrees, we're pretty much stuck there. It's going to be hard to get back down. And a lot of that is related to the incredible heat trapping capabilities, the heat sinks that are the oceans. So you kind of, because the ocean absorbs so much heat, the atmosphere warms up quicker. So right now, when we're in a warming stage, the air is getting warmer closer to the ocean. However, when we stop that, the ocean and the air are going to reach kind of equilibrium again. So that was the kind of the only notable change between the 27 and the 2007 and 2014 reports. There are some different, significantly different impacts. I guess another thing that's changed is sea level rise projections are a lot higher than they were. Arctic warming levels have been much faster than anticipated, but more of the same, more certainty, but the same large conclusions. And I do encourage you, those of you who are either feeling very bold or suffering from insomnia, to have a crack at one of the IPCC reports. If nothing else, just to be kind of overwhelmed with the amount of information. It's a pretty daunting or impressive or overwhelming experience in my opinion. And they're all publicly available. You don't even have to attribute the images. All of the authors are also volunteer. So it's a pretty interesting process for sure. Okay, thank you everyone for your questions and for your attention and for joining us on this lovely evening. So next week, going to talk a little bit more about the Community Climate Action Plan and then think about climate impacts and adaptation in Squamish. So thinking about things like forest fires and sea level rise and what we're going to do about that. Because if you recall from that graph that we looked at earlier, even in that 2.6 degrees Celsius, 2.6 RCP scenario, 1.5 degrees Celsius is still going to have a lot of things that we're going to have to adjust to. So regardless of what we do, we have to. Thank you again, everyone. I hope you have a wonderful evening and hope that some of you can come next week.